The following edited and narrated DVD will document Aquatic Inspections' wet inspection and cleaning of Marshall Potable Reservoir for the Lake Hemet Municipal Water District. Marshall Reservoir is a welded steel potable water storage facility located in Hemet, California. The reservoir is 40 feet tall with a diameter of 95 feet. Maximum storage capacity is 2 million gallons. The wet inspection and cleaning took place on January 24th, 2013. A ladder guard, and safety cage are located at 12 o'clock, and the ladder guard was securely padlocked at the beginning of the inspection. The exterior of the facility appears to have been repainted since our last inspection in 2009, and the paint on the ladder guard, and safety cage is in good condition and free of corrosion. A target or level sight gauge is located on the shell next to the ladder, terminates in the middle of ring number 3, and did appear to be operating properly throughout the wet inspection and cleaning. The reservoir was erected on a concrete ring wall or foundation. The foundation is in good condition. Slight hairline cracks are present in a couple of areas. These are considered normal. The overflow line exits the facility near the top of ring number 1 at approximately 1 o'clock. The overflow line is secured to the shell by 4 steel standoffs. The paint on the overflow line is in good condition and free of corrosion. A 12-inch outlet line is located at the base of the shell at 1230. The valve stem for the line is not secured. A slight amount of delaminating paint is located on the line. The delaminating paint has resulted in exposed primer in a couple of areas. Corrosion is not present. Water leakage is not located on the outlet line. The paint on the exterior shell is in good condition. The paint is not chalky. Chipped or delaminating paint are not located on the shell. Graffiti or indications of vandalism are also not located on the exterior shell of Marshall Reservoir. Erosion is not present at the base of the facility. The first of 2 round shell manways is located at 6 o'clock. The paint on the manway is in good condition. Corrosion is not present. Water leakage is also not present. Both the level sensor line and inlet line are located at the base of the shell at approximately 11 o'clock. The level sensor line is insulated, appears to be in good condition without water leakage. The majority of the paint on the inlet line is in good condition. A minimal amount of corrosion is located on the line. The valve stem for the line is not secured. Indications of water leakage are not located on the inlet line. It does appear that the exterior of the facility has been repainted since our last inspection in 2009. In a couple small areas on the inlet line, the paint is losing flexibility and cracking. The cracked paint has resulted in extremely light surface corrosion. The second round shell manway is located at the base of the shell at 11:45. The paint on this manway is also in good condition and free of corrosion. Water leakage is not present. The manufacturer's nameplate is secured to the shell above the manway. The facility was erected in 1990 by San Luis Tank Piping Construction Company Incorporated, is 40 feet tall, 95 feet in diameter, and has a maximum storage capacity of 2 million gallons. The access hatch located on the roof was not securely padlocked at the beginning of the inspection. The interior of the hatch is coated with epoxy, and light surface corrosion is present in a few areas on the interior of the access hatch. Possibly moderate corrosion is present in a couple of areas on the lip of the hatch. Corrosion was observed on the interior access ladder. The paint on the safety railing located on the roof is in good condition and free of corrosion. Safety concerns prevented the diver inspector from conducting a thorough inspection of the roof structure. Light surface corrosion was observed in many small areas on the roof structure where the paint is losing flexibility and cracking. It is our understanding that the roof was repainted approximately 3 years ago. Many small areas of light surface corrosion are located on the roof. It was raining at the time of the inspection, and safety concerns prevented the diver inspector from leaving the area where the safety cable is located. A single vent is located in the center of the roof. The majority of the paint on the vent cap is in good condition. Both a large and fine mesh screen are located on the interior of the vent structure, and both screens are in good condition without holes, tears, or voids which would allow contaminants to enter the facility. Here's a close-up of the corrosion that is taking place in many areas on the roof structure. The paint on the roof structure is in fair to poor condition. Here the diver inspector is pointing out an area where the paint is losing flexibility, cracking, and that has resulted in light surface corrosion. We're now going to begin our interior inspection, beginning at the manway, which is located next to the interior access ladder. The interior of the manway is coated with epoxy. What appears to be pinhole type corrosion is present in a few areas on the interior of the manway located at approximately 1145. Cracked delaminating epoxy coating has resulted in light surface corrosion in many areas on the shell near the manway and the target base. Corrosion has consumed portions of the target base. The guide wires for the target are no longer secured to the base. Dense corrosion is present on the target base in these areas. Additional corrosion is present here at the transition from vertical wall to floor next to the interior access ladder. The paint is losing flexibility, cracking, and delaminating in many areas on ring number 5. The interior access ladder is also coated with epoxy. Many small coating blisters are present on the ladder. The majority of the blisters have not ruptured. Where blisters have ruptured, light surface corrosion is present. A few additional areas of corrosion are present on ladder rungs and rails where coating defects are located. Additional coating blisters are present here on the other ladder rail. Corrosion is also present in many areas on the shell behind the ladder. This is the weld that connects ring number 4 with ring number 5 on the shell. Corrosion is present on this standoff. All standoffs for the ladder do appear to be securely welded to the shell. Cracked epoxy coating is present in a few areas next to ladder standoffs. Here's a close-up where the epoxy coating is losing flexibility, cracking, and delaminating on the weld that connects ring number 4 with ring number 5. We've now returned to the transition from floor to shell. Many small areas of light surface corrosion are present on ring number 5. This is a vertical weld seam on ring number 5, and additional areas where the coating is losing flexibility, cracking, and delaminating, resulting in light surface corrosion, are present next to the weld seam. Here's a close-up where the coating is losing flexibility and cracking. Light surface corrosion is present in many areas on ring number 5. The shell is also stained in many areas. Additional areas of cracked coating are located on ring number 4 next to the weld that connects ring number 4 with ring number 5. Light surface corrosion is also present in many areas on ring number 4. We're now following a vertical weld seam on ring number 4. Additional areas of light surface corrosion are present on the shell in this area. We've now reached the weld that connects ring number 4 with ring number 3. The shell is stained in these areas. An oily residue is located on the shell in many locations near the waterline. We're now ascending a vertical weld seam on ring number 3. The oily residue is visible here on the weld that connects ring number 3 with ring number 2 and is present in many areas on rings number 2 and 1. This is not loose sediment or residue. This is an oily residue which is stuck to the epoxy coating. The water column is slightly aerated. We've now reached the weld that connects ring number 2 with ring number 1. Stains are present on ring number 1 in a few areas below rafters. The majority of the water line was free of floating debris or surface scum. A slight amount of oil will be documented later in the inspection. A portion of the overflow weir box is located below the water line. The overflow weir box is coated with epoxy, and coating defects have resulted in light surface corrosion in a few areas on the overflow weir box. It does appear to be securely welded to the shell. Additional areas of pinhole type corrosion are present in a couple of areas on the welds. The shell is stained around the overflow weir box. The center pole is the only support column located on the interior of Marshall Reservoir. The epoxy coating is heavily stained near the waterline. Coating defects were not observed on the portion of the center pole closest to the waterline. The diver inspector is now descending on the center pole, documenting the condition of the epoxy coating. Beginning approximately 20 feet from the floor of the reservoir, coating defects were observed on the center pole. The coating is losing flexibility, cracking, and delaminating in many areas on the center pole in this location. The corrosion that was observed on the center pole is very similar to the corrosion that was documented on the vertical walls on the interior of the facility. The coating is losing flexibility and cracking in many small areas, resulting in many areas of light surface corrosion. Many additional areas of light surface corrosion or pinhole type corrosion are present as the diver continues to descend the center pole. A few larger corrosion nodules are located on the center pole as we approach the base of the center pole and the floor of the facility. A few larger corrosion nodules are present in this area. The base plate for the center pole is also coated with epoxy. Aquatic Inspections previously addressed many areas of corrosion at the transition from base plate to floor. The majority of the epoxy patches are in good condition. Corrosion was observed in a few areas on the edge of patches. Corrosion is present on the floor in many areas near the center pole. The floor of the facility is coated with epoxy. Epoxy patches are also present in many areas on the floor of the facility. Here's an example where corrosion is located on the floor. The floor is also heavily stained in this area. Many large areas of light surface corrosion similar to these are located on the floor directly downstream from the inlet line. Similar areas of corrosion were not observed where the sediment was located. The majority of the sediment located on the interior of the facility prior to the wet cleaning consisted of heavy sand. The sediment is slightly scattered as we move away from the center pole. Sediment ranging in depth from 1/16 inch to approximately 3/4 of an inch were located on the floor of the facility prior to the wet cleaning. The majority of the floor was covered with approximately 1/8 inch of sediment. The sediment consists primarily of heavy sand. Up to 3/4 accumulation of sand was observed and removed from the floor on weld seams. We've now reached the area where the outlet line exits the facility through the shell. The facility was not isolated for the wet inspection and cleaning. The butterfly valve is in the open position. Dense corrosion is present in a few areas on the butterfly valve. Light to moderate corrosion is present in a few areas on the interior of the epoxy-coated outlet line. Coating defects have resulted in light surface corrosion in a few areas near the line. The coating is also losing flexibility, cracking, and delaminating in many areas on the shell near the outlet line. This is a transition from floor to shell. A few coating defects are present at the base of the shell in this area. The coating appears to have been scratched in a couple of areas. We've now returned to the floor, which is covered with sediment at this time. At the conclusion of the wet inspection, all of the loose sediment and debris will be removed from the interior of the facility. Here, a corrosion nodule is visible through the sediment. The diver inspector has removed the corrosion nodule in this area, and slight metal loss is taking place in this location. The diver inspector is now approaching the manway located at 6 o'clock, which is also coated with epoxy. Coating defects are present on the shell in many areas below the manway. Cracked coating is present in many areas on the shell around the manway. Coating defects are also located on the interior of the manway structure. Light to moderate corrosion is present in a few areas on the lip of the manway. Dense corrosion is present in a couple of areas at the base of the manway door. The epoxy coating is lightly stained, and the stains are easily removed by contact with the diver's gloved hand. It appears that contaminants may have been present during the time the manway door was coated. Light surface corrosion is present in a couple of areas. We're continuing to move clockwise through the interior of Marshall Reservoir. This is the transition from floor to shell as we move away from the 6 o'clock manway. The shell is heavily stained near the floor. The majority of the floor in this area is covered with a sandy sediment, and a few corrosion nodules are present. A few large chips of what appear to be concrete were observed on the floor and removed by the two-man cleaning team. Small pieces of corroding metal were also observed in many small areas on the floor directly downstream from the inlet line. The sediment is also slightly scattered in this area. Light surface corrosion is present in many areas on the floor where the sediment is not located. The floor is heavily stained in a few areas. Light surface corrosion is present in many areas in this location as we approach the inlet line. Light surface corrosion is present here. Aquatic Inspections would recommend that consideration be given to recoating the interior of the facility. In many areas on the floor, the lowest 20 feet of the shell and the lowest 20 feet of the center pole, the coating is losing flexibility, cracking, and delaminating, resulting in light surface corrosion. Additional large pieces of concrete chips are present on the floor and being removed by the two-man dive team. All of the loose sediment and debris was removed from the interior of the facility at the conclusion of the wet inspection. We've now reached the section of the vertical wall where both the level sensor line and inlet line are located. The interior of the level sensor line appears to be slightly obstructed with moderate corrosion. The interior of the inlet line appears to be coated with epoxy. It is heavily stained. Once again, the facility was not isolated for the wet inspection and cleaning. The butterfly valve is in the open position. Light surface corrosion is present in a few areas on both the butterfly valve and the interior of the inlet line. Obstructions are not present on the interior of the inlet or outlet lines. We're continuing to move clockwise away from the inlet line and towards the ladder. Coating defects have resulted in a few areas of pinhole type corrosion and a couple small corrosion nodules at the base of the vertical wall in this area. We've now reached the manway where we began the interior inspection, and we're going to ascend on a vertical weld seam on ring number 5 to further document the condition of the epoxy coating on the shell. The coating is losing flexibility, cracking, and delaminating in many small areas near this vertical weld seam, which have resulted in light surface corrosion. We've now reached the weld that connects ring number 5 with ring number 4, and many additional areas of cracked coating are present here near the weld seam. We're now ascending on our vertical weld seam on ring number 4. Pinhole type corrosion is present in many areas on ring number 4 where coating defects are located. Here's an example where coating defects have resulted in pinhole type corrosion on the shell. With light surface corrosion present in many areas on rings number 4 and 5 and in a few areas on ring number 3, Aquatic Inspections would recommend that the interior of the facility be recoated. Many additional areas of corrosion are located on the lowest half of the center pole, and extensive corrosion is present on the floor of the facility. We're continuing to ascend on the vertical wall. This is a vertical weld seam. An oily residue is present in many areas at the top of ring number 3, where ring number 3 and ring number 2 are welded together. The majority of the epoxy coating on ring number 2 does appear to be in good condition. An oily film is present over the majority of the epoxy coating. This is the weld that connects ring number 2 with ring number 1. Stains are present in many areas on ring number 1 below the waterline. A minimal amount of corrosion is located on ring number 1 below the waterline. A slight amount of oily film or residue was observed on the waterline in one location. We're now going to document the above water portion of the facility. The roof structure is coated with epoxy. The condition of the epoxy coating ranges from good to poor. Corrosion is present in many areas on rafters and roof plates. Moderate corrosion is present on the edge of a few rafters. Slight metal loss appears to be taking place where moderate corrosion is located. Light to moderate corrosion is present on tie rods in a few areas. In this area, light surface corrosion is present over the majority of rafters. Moderate corrosion is also present in a couple of areas. The facility was filled to spill for the interior inspection and wet cleaning. Here, the majority of the hat plate is covered with light to moderate corrosion. Moderate corrosion appears to be present at the top of the hat plate in between where rafters are welded to the hat plate. All rafters do appear to be securely welded to the hat plate. Twisted or bowed rafters are not present. Here are some additional examples of the corrosion that is taking place in many areas on rafters and roof plates. Moderate corrosion is present here in a couple of areas on the edge of a rafter. The majority of the epoxy coating on the overflow weir box above the water line does appear to be in good condition. Light surface corrosion is present on the lip of the line. Stains are present on ring number 1 above the water line in many areas. Light surface corrosion is also present on ring number 1 above the water line. All rafters appear to be securely welded to rafter clips. The float for the target is also in good condition and securely attached to all 3 wires. An area of dense corrosion and moderate to severe metal loss is located on the shell directly behind the interior access ladder. Aquatic Inspections would recommend addressing this area. We're now going to document the removal of all loose sediment and debris from the interior of the facility beginning at the 1130 manway. The loose sediment and debris has been removed from the floor around the target base and the interior access ladder. The facility was not isolated for the wet inspection and cleaning. The removal of sediment did reveal additional areas of corrosion. Many small corrosion nodules are present on the floor. The diver inspector removed approximately 12 corrosion nodules for the floor. Moderate corrosion is present in this large area. Here, another corrosion nodule has been removed and metal loss is not taking place in this location. Slight metal loss is taking place in this area. This appears to be representative of the metal loss that is taking place on the interior of the facility. In approximately a third of the areas investigated, moderate metal loss was taking place. A third of the areas, slight metal loss was taking place. And in the other third of the areas, metal loss was not taking place. Many small coating blisters are located on the floor in this area. Many of the blisters have ruptured, resulting in moderate to light corrosion. Here's another area where moderate corrosion is taking place on the floor. Aquatic Inspections would recommend addressing the areas where metal loss is taking place. The slight and moderate metal loss seem to be taking place in areas where medium-sized to large corrosion nodules are located on the floor. Approximately 150 of these areas are located on the floor. Until the facility can be recoated, we do recommend addressing the areas of metal loss. The loose sediment and debris has been removed from the floor around the outlet line. Many small coating blisters are located on the floor. In a few areas, pinhole type corrosion is present where either a coating blister has ruptured or in this area, the coating is losing flexibility and cracking. These areas represent pinhole type corrosion and metal loss is most likely not taking place. All the loose sediment and debris was removed from around the center pole and center pole base plate. The diver inspector is now swimming away from the center pole, documenting the removal of all loose sediment and debris. The floor is lightly stained in these areas. Pinhole type corrosion and very small corrosion nodules are present in thousands of areas on the floor. Here's a concentrated area of light surface corrosion and pinhole type corrosion. A few moderate sized corrosion nodules are located in this area near the transition from floor to shell. All the loose sediment and debris has been removed from this area. We've now reached the manway located at 6 o'clock. Here a concentrated area of moderate sized corrosion nodules is located on the floor. The diver inspector has now reached the inlet line and level sensor line. The loose sediment and debris has been removed from this area. The majority of the epoxy patches located on the interior of the facility are in good condition. Corrosion was observed in a few areas on the edge of existing patches. We've now returned to the manway and the target base. We've now returned to the interior access ladder, and this concludes Aquatic Inspections, wet inspection and cleaning documentation for Marshall Reservoir. We would like to thank the Hemet Municipal Water District for retaining our services. If you have any questions about the wet inspection or cleaning, please don't hesitate to contact us at 760-753-4812, or you can email us at roberts at aquaticinspections.com.